law, you need to write P. Write PV because of the scenario. You need to P1 equal to P2 V2. For 10 power 2 kilopascal will be your P1. Volume 1 will be 6 liter. Volume, it asks you to find volume P2 with pressure P2 equal to 1 kilopascal. Before that, give you some recap of conversion liter into meter cube. Liter equal to 1 multiplied 10 negative 3 or 0.001 meter cube. 1 liter equal to 10 power 3 or 10 power 3 cm cube. And if you convert to meter mm cube, it will be 1 multiplied 10 or 6. This is important. And the question is in meter cube or cm cube, or you should be able to convert. Because later on, you will link this mm, link to the unit of liter into mm, and so on. Okay, so without doing the steps, the volume will increase or decrease. Volume or less volume if you have lower pressure. By using Boyle, what happened? If you decrease the pressure, what happened to the volume? Go up or go down? Go up, yeah? So if your answer is less than this one, it's less than 6 liter, means your answer is wrong. This is a general quick check. Right. Okay. So if you do the substitution, it will be 24 liter. Okay, you cancel the 10 power 2 also. So directly multiply 6. Be careful on the unit. Sometimes I will trick you by removing the K. I'll just give you Pascal. Always assume it's a kilopascal. Familiar with your calculator. You should know how to press 10 power 2, so on. Some of you use a new calculator, you bring new calculator into exam and don't know how to use. Okay, another one, same, Boyle's law also. A circular takes a syringe filled with 16 ml, milliliter, air from the surface with the pressure 2 kilopascal to an unknown depth. The volume of the air in string at this depth is 75 ml. What is the pressure at that depth? If the pressure increased by additional 100 kilopascal every meter depth, how big is the snorkel? So this one is application of Boyle's law. Here you do not mention temperature, so we assume temperature is right. So here in the pressure, here volume. Then from the pressure, you find T2, you use this statement, you find the depth. Okay? So the working will be mean the thinking strategies will be, right, V1 equal to P2 V2, and then substitute the value. You have P1, you have V1, and then you have V2, you find P2, then you use P2, you divide by 100 kilopascal, means you go, right, 1 every 10 meter, you increase additional 100 kilopascal. Okay. So this one you find, so this actually is your homework. Here it's just a direct application of Boyle's law. Just see if you're able to see. So flask contain gas sample at pressure X. If the volume container triple at constant temperature, this one confirm Boyle's law. So V increase triple, V2 become 3V1. If you write equation X, if you have this scenario, your V1 equal to V1 and V2 equal to 3V1. What is the pressure after volume change? So here, we use the same equation. P1 is X. So same, X, V1 equal to P2. P2 you need to find. So if you don't know, you just put Y. P2 equal to Y. So you write Y P1. That's a normal mathematics. So you want to find your Y. So you move your then you cancel. V1, it will be quarter of X. Right. Now we learn second law. We already done Boyle's law. Now we learn Charles' law. Charles' law related to volume and temperature while the pressure is constant. Charles' law related to volume and pressure. So this one related to a normal scenario that you see if the temperature of the air is hot, it will rise to the higher, but hot air float and cool air sink. That's why your aircon you put in high position rather than low position. You put your aircon in very high position because cold air will drop. And so on, yeah. So this also explains why hot balloon can float and so on. Okay. What does the phenomenon that you see? The warming will decrease the density. How you get density? You get mass divided by volume. How you get rho in physics? Rho equal to mass divided by volume. And application in daily life is low density gas float, high density gas will sink, right? So colder air will sink, hot air will rise. So this will link to question section C or the third component of the thing. So when you get, if you ask you to apply Child's rules, it will ask you whether the thing will float or not compared to initial things. Huh? So let's watch experiment to see. Initially, I want to do this, but too many things need to prepare, but I just use video, right? So what does this video will see? Try to observe this guy will use same water. One is hot water, one is ice cube water to simulate the Child's law. You will see he will use straw. What will this man will do? He will use this straw to suck either cold air or hot air. I think this is cold air. You see the ice cube here. He will use cold air, suck, and then he will go and use the suck another one here. You'll see how he do. Then you see whether does it mix or not. Because just now we see if we have hot, medium, the thing will float. Cold will go down, right? So this explain this one. Okay, it should play. YouTube.
Hi, I'm Jared back with another simple science demonstration on the whole idea that warm air rises, cold air sinks. And it's true for water. And the cool thing about this is it's kid friendly, kid tested, mother approved. Nobody's going to get hurt. We have hot water, cold water, and we don't want kids dipping their hands in there, coming out with third-degree burns. We want a safe way for kids to really look at what's happening, analyze it, think about it again and again and again. That's what science is. So we have a very, very simple setup here. You can see I have a jar of water. It's hot, hence the red. I have a jar of cold water. It's cold, hence the blue. And all we're going to do is put the food coloring in. Take the lid off. You don't have to be conservative here. You just squirt it in. You want it to be a nice, dark, deep red. And watch how quickly that red actually disperses and just totally fans out in all of the water. It's not taking long. And compare that with the blue because it's actually interesting scientifically what's happening. Squirt some blue in past the ice. You can see the blue sort of stays together. It's not spreading out as quickly as the red. That's actually part of the process of what's happening here. The molecules here, the water molecules are heated, so they're moving quickly. They're moving, and it's actually helping to stir up that water. You can't see it. Sort of an invisible stir. Here, it's not moving so quickly. You can see it's not really spreading out there. So I'm going to speed it up with my straw. Stir it up there. Stir this one up here. Make sure it's good. Now, what I want to do is create a column of separation between the two colors. See what happens. And it's a real simple principle. And we've all done this with soda. Stick the straw in your soda, put your thumb over top and pull it out, and the soda stays in the straw. Well, that's a different scientific concept. So we're focusing here on just one simple concept. So I'm going to start with the hot water first. Dip it in, put my thumb on top, and ta-da, it's staying in there. Now here's the magic. It's not magic, it's science. I'm going to move it over, put my straw deeper into the blue, let my thumb off, put my thumb back on, and trap the water inside. It sounds so complicated, but it's not. Here we go. Deeper, off, cap, and I have a beautiful column. And the red and the blue aren't mixing. I have the hot water on the top, the cold water on the bottom.
It's cold.
And it's not mixing. Why? Warm air rises, cold air sinks. That warm water is a whole lot lighter and less dense than the blue, and it's not separating. I can look at it. I'm a kid. I'm not getting burned. Beautiful. Now, if I leave this sit long enough, the temperatures will even out. It'll start to mix. You can see it sort of starting to happen right in the middle. It's cool. What if we reverse it? That's where you see the science happen. But I'm going to start with the cold and then go to the hot. How do kids think about what's going to happen? Have them predict. Have them make a hypothesis and test it. They mess up, so what? You dump it out. It's cool. I have my blue. Now I'm going to go a little deeper. Take my thumb off. What happened almost instantaneously? They're mixing. You can see the red actually rising in the blue, and they're mixing. Why? Warm air rises, cold air sinks. Warm water rises, cold water sinks. Such a simple concept.
Okay. Also explain what happened, yeah? So some magician, they use one in the tricks, in the Michigan tricks. So if you see something mixing, or if you want to go into F&B later, you can do this kind of experiment where we'll mix hot drinks and cold drinks. If you want to do a good barista or something, you mix cold syrup or hot syrup, and then you see whether it mix or float. Right. So also explain famous string in Sarawak, the 3-layer strings. Sometimes it mix, sometimes it doesn't mix because of this principle. Okay. So at least you're able to explain what you learned in your foundation. All right. So this is a Charles law. As you can see, if you plot volume versus temperature, if you increase temperature, volume increase. Okay. At the end, we like equation. Charles law gives you V proportional to temperature. V proportional to temperature. And we like to put V in our left-hand side equation. Same as what you've seen in the Boyle's law just now. We convert the inverse sign into a constant. So how we write? V equal to constant T. And this is Charles' law. And you can also use the same equation as Boyle's law. Given V1, T1, you should be able to find V2, T2. Okay? This one you can read now. Okay. So what actually happened? If you increase the temperature, particle move faster, more energy. If the pressure remain constant, volume will increase. Volume increase because the gas pressure, the particle move faster. Right? So if you put a balloon, you put in the boiling water, you see the balloon will expand. Okay? The balloon expand. If you put in the cold water, the balloon will sink, will become smaller size. So this explained by Charles' law. Don't confuse Boyle's law and Charles' law. Yeah? Okay, Charles' law, pressure constant. Eh? Pressure constant. Eh? Don't confuse between Charles' law and Boyle's law. Okay. So you convert the proportional sign into equal sign. You need to put in constant. Right? So if you have a constant, we always put constant at the right hand side. So from here, you generate another new equation, which is V divided by T will equal to constant. If you compare Boyle's law just now, PV equal to constant. That's why we can compare P1 V1 equal to P2 V2. So you have the same equation, V divided by T equal to constant. Then you can compare two scenarios by taking V1 divided by T1 equal to V2 divided by T2 because they are constant. Yeah, right. Because the constant doesn't change. The constant means the parameter that for the same gas, same pressure, right? Okay. Nothing complex here. Another tutorial. I highlight the temperature here in Kelvin. So if the question gives you Celsius, please use Kelvin. Boyle's law, Charles' law, or other law, they are using Kelvin. Okay, like for example, this example, a 2.737 liter sample of gas. Boyle's law, Charles' law, they apply for gas. They apply for gas, not liquid, not things. Right, then heated to a different temperature with no change in pressure. So if you see this no change of pressure, it is related to Charles' law. Determine final volume. So again, you put V1, T1 equal to V2, T2. There will be some parameter missing, where is the V2 missing. Rearrange the equation, cancel out the same unit. You arrive at liter. Put in liter, yeah? So some question in test 1 and final exam will ask you to put in centimeter cube or meter cube. Okay, I show you the steps. You need to show me the Charles' law. You need to write V proportional to T. Then you need to write V equal to constant T. Then you rewrite V divided by T equal to constant. Then for two conditions, V1 equal to T1 equal to V2, T2. Substitute the value. Cancel out the unit. Get 2.83. Okay, the concept is easy, as long as you understand what is Charles' law. The rest is just substitution. Okay, nothing complex, yeah? Right. Next one. Next one will be these two questions. In your tutorial question, you can see this one as your homework. If you want, you can do and try out. Yeah. So, yeah. Let's go. Okay, this one I skip. If you understand already, just check your answer. Okay, so this one just show you. If you want to convert Celsius into Kelvin, you need to plus 273. Okay, that's another two equation. Next, we have Charles' law, we have Boyle's law. We combine these two, that we have pressure, volume, and temperature, which is called ideal gas law. You combine them together by writing them equal to constant. Right, PV equal to constant and V divided by T equal to constant. You combine these two, right? You get PV divided by T equal to constant. This is when you see the question asks you to use the combined gas law. You need to write this one. PV equal to constant, which is the combined gas law. Combined gas law. In later section, you will see what is this constant. Any question on these slides? Makes sense, The mathematics makes sense to you, Okay. Okay, so for a sample, when we use the combined gas rules, when we have a sample of gas, we'll talk about gas, huh? Gas under two different sets of conditions, we use combined gas law. Means we, the question state give you different temperature, different pressure, then you use combined law. Okay, then you can use PV1 equal to PV2, PV1 divided by T equal to P2 V2 T2. This is when you have the question do not say temperature constant, do not say pressure constant, but give you three parameter, give you pressure, volume, temperature, then ask you to find another missing parameter. Then you use combined gas law. In your answer, you need to tell me what equation you use. You need to write combined gas law equal P1 V1 divided T1 equal to P2 V2 divided T2. Then you substitute the answer, the value. Yeah. Okay. One thing you will see in the question, when the question purposely asks you combined gas law, the keyword will be amount of gas is constant. Amount of gas here is, if you study chemistry, how we quantify the amount will be number of Avogadro, something moles, right? One moles equal to certain of molecule and so on. Yeah. Okay. So this is the assumption. Okay, so this is another application of combined gas laws. So it gives you a scenario. A piston again give you the volume, 3.65 liter. Pressure at the bottom mountain is 101 kilopascal. Temperature is 302 Kelvin. Again, in test, I'll put Celsius. The pressure at the top mountain is 91.7 kilopascal. Temperature is 291 Kelvin. What is the volume of cylinder at the top of the mountain? So here basically play with P, V, and T. One is missing, which is a V2. So you use combined gas law, substitute the value. So in your answer, you need to write P1 equal to what, P2 equal, V1 equal to what, T1 equal to what. Then you substitute. Okay. So way of solving problem, write the general equation, what equation you use, then substitute. Remember to write the unit, cancel out the unit, you will get the answer. Okay, V2 equal to 3.87 liter. So far, we are still playing with a very big quantity, which is a pressure, temperature, and volume later. In later chapter, you will play with amount of gas. Okay, we are now at combined gas law. We will use P1 V1 divided by T1 equal to P2 V2 divided by T2. Okay. Your test 1 or test 2 won't so direct as this kind of question. Yeah, it's just a tutorial question. You need to think a little bit when it comes to a test. Okay. This is another example. But you see what's different? It gives you milliliters of mercury, which is linked to the previous section before the break. It asks you to convert 1 atm into certain mercury and fine, right? So it gives you V1, 158 liter at pressure so and so, at temperature so and so. If the gas is compressed to a V2, heated to a T2, what is the final pressure in milliliter of mercury? So you need to convert kilopascal into mmHg. So you need to go through kilopascal equal to how many atm? Atm convert back to mercury. So this will be a combination. This kind of standard will be your exam question standard. It will link to different section of the chapter. Yeah. So I'll show you the steps. You can ask me question if you have problems. We use combined gas law. Rearrange the equation. Substitute value. Just need to be careful on the unit. In the test, we will use Celsius. I keep reminding you. So we will give you Celsius. And we'll use the 10 power something in the question. So you need to be good in conversion of exponential numbers. Right? So we cancel all the similar units. P2 will be 167 kilopascal. You link this kilopascal into atm, link to mercury. Yeah. So far, no complex. This one. Yes. Oh, yeah. It should be cancel the ML. Yeah. So if this one come out in your assignment, don't just follow the cancel. You need to cancel the correct one. Right. So there are some highlights here. So be careful on the conversion of Celsius. Let me see. Okay, these are the two additional questions. If you want, you can see. Right. All right. Now we move to another law. We have covered Boyle's law. We covered Charles' law. We combine Boyle's law, Charles' law. We get combined gas law. Now we go to another law. Avogadro. Avogadro law, you see the Avogadro? It means amount of gas. You learn Avogadro number 6 point something 10 power 33 atoms or molecule. That one is Avogadro number. So just now, combined gas law is amount of constant, amount of gas constant. What happens if something change? Which is the amount of gas change? We'll use Avogadro law. So in the experiment, we measure volume of gas at a constant temperature and pressure, but we use different moles. We measure the volume. So let's say you put in 0.2 moles of some gases. You measure, let's say you put in oxygen, 0.2 moles of oxygen. You measure inside container how many pressure, how many volume, right? Then you increase the moles, you see how many. So as you can see here, this is a linear line. From this experiment, you should able to write linear equation, which is y equal to mx plus c. Right? Recall your mathematics, huh? Straight line, y versus x axis. I write something on the whiteboard here. So if you have a linear line, this relationship is y equal to mx plus c. C is the intersection, right? Intersection. This is c is intersection, which is the cross of this lower line. So if you refer to Avogadro law, this chart, c is 0. What is your y? Your y is volume. M is the constant. Your x is number of moles. It is n. So you can derive this equation. All right. The constant you can find y1, y2 minus y1 divided by x2 minus x1 to find the m. Okay, this one is your simple mathematics. Okay, so this one you experience the balloon when you inflate, balls will become bigger and bigger as you add more and more gas particles, right? So when you add more gas particles, you increase the volume. Okay. So I highlight, we use Avogadro law to calculate volume as long as pressure and temperature are constant. So if the pressure and temperature do not constant, like what you learn in Boyle's law, Charles' law, in a combined gas law, then you use combined gas law. If you are given different temperature and pressure, then you use combined law. If you see the question mentioned, pressure, temperature constant, means it forces you to use Avogadro law. Okay. So as you can see here, if I write something on the whiteboard here, you know that V equal to constant N. We always like to use write the constant on the right hand side. So V divided by N equal to constant. This one is Avogadro law. So if you have two conditions, you can write V1 divided by N1 equal to V2 divided by N2. N is the mole. N is the number of mole. Okay. How you find moles? You need to think back chemistry 1. No? How you find mole? You take the weight divided by the molecule mass. This one you need to use periodic table. To find the N, you need to use periodic table. Okay, the N, amount of moles, N equal to mass in gram divided by atomic mass. Or in the periodic table, you see the numbers there. For example, carbon is 12 gram in periodic table, right? So gram divided, this one atomic mass is gram over mole. So if you convert the unit, you will get mole. Can you see the conversion of unit here? Cannot. Why you take mass divided by atomic mass, you get mole. You see the unit. So the mole will go up, you become mole. Okay, so this one will not give you, this formula will not give you in the chemistry 2 test or final exam. We assume you didn't know in chemistry 1. Okay, so let's see example. You are given V1, 4.8 liter of helium contain a certain mole. If you see volume and mole is under Avogadro law. How many addition moles you should add to reach volume this one? He asks you additional moles. He do not ask you the final mole. This will be the catchy word. With this, we like to use this word in test or final exam. We ask you additional mole. We do not ask you the final mole. There's a difference. Huh? Okay, so Avogadro law is constant pressure and temperature. So you need to use Avogadro law. You write V1 equal V1 divided by N1 equal to V2 N2. Then you substitute the value, you get one missing parameter. Okay, I highlight, need to write your law there. Rearrange the general equation, substitute. Then you cancel the volume, the liter, you get 0.29 mole. The question asks you additional mole. So how many additional mole? How many additional mole you need there? 0.07. Right, you take this one, 0.29 minus 0.22 lah. He asks you additional mole. Okay, so by now you should already can identify what type of question belong to which section of the class. Okay, if you see something, it'll give you some hints. What does it related to? Which law, right? Okay, so answer is 0.07 mole. Huh? You need to show me how you get 0.7 mole. Okay, yeah. Okay. This one additional question. If you want, you can do and then show me your working. Right. This is just additional. I think I give you this one also, right? Do I give you in the tutorial? No, right? No, then this is additional. We assume we already know. With this, number of mole equal to, you take mass, how many gram? Unit is gram, not kilogram. So in the test, we like to give you kilogram. So you need to put in gram divided by molar mass, capital M. Molar mass you get from periodic table. Molar mass, unit of molar mass is gram over mole, gram per mole. Okay, so this will give you how you convert from mass to mole, from mole to volume, and so on. Okay, from the diagram here, 1 mole equal to, this is also, we assume you know, 1 mole equal to 6.02 10 power 23 particles. It can be atom or molecules. These are Avogadro number. We assume you already know. Huh? We won't give you in the final exam. The rest you can get from this one. Okay, later we'll learn something called standard temperature volume of gas. Later, we use this one. Just at the current stage, just accept 1 mole of gases will give you 22.4 liter at standard temperature pressure condition. This one later. We'll come into this one in maybe chapter 3 or later section. Okay, so far just accept. Just accept. If you want to find the volume at standard temperature and pressure, 1 mole will give you 22.4 liter. Okay, these are the things. Now we go into the last gas law. We will combine what we learned so far. It's called ideal gas law. We link pressure, volume, temperature, and moles together. So now we learn, just now what we learned, we have P, we have V, we have T. Now we have one more N, number of moles. We want to link these 4 parameters together using ideal gas rules. Okay. So again, in the question, you need to tell me what laws you use. At the Boyle's law, Charles' law, Avogadro law, you need to write something proportional to something, only you convert to constant. Don't skip these steps in your working for test or final exam. Write the theory part, what law equal to what definition, then only you extend to constant. Don't straight away use the equation. Don't straight away like give me P1V1 equal to P2V2. You need to explain what is that, from what law you use. Because P1V1 it is from Boyle's law. P1V1 is not Boyle's law. It's just a comparison of two conditions using Boyle's law. So don't confuse the equation. So without this one, you won't have marks for the definition. If you straight away use P1V1 equal to P2V2, that one will be under your working part already. You don't have marks for definition. So these are the thing that when we mark your paper. Okay, we combine this one, we'll get this one. V equal to exponential proportional NT-PV. Straight away, we will use V equal to RNT divided by P, or I prefer another form. We give you PV equal to nRT. I straight away remember PV equal to nRT. With the R is the ideal gas constant. Ideal gas constant will be given in the question. R is the constant. So ideal gas flow equal to PV equal to nRT. Don't use the wrong place. If the question asks you Boyle's law, you use Boyle's law. If the question asks you ideal gas, you use ideal gas. Right, in your notes, R equal to 8.314 unit is liter, kilopascal divided by mole Kelvin. How you know the unit? If you derive from the ideal gas equation, you rearrange the ideal gas equation, R equal to PV divided by NT, right? So what is the unit of pressure? Kilonewton or kilopascal. Volume is meter cube or liter. N is mole. T is Kelvin. In later chapter, you need to be careful on the R value. Sometimes we will give you different R value by changing this parameter L. We'll remove the L, become either is mercury or it become mm meter cube and so on. So a bit different. So when you read textbook also, you need to able to understand why sometimes 8.314 the back got 10 power something because of the unit that they use. So in our case, we use liter, kilopascal over mole, Kelvin. Okay. This one to find what is R. Derive Boyle's law. So PV equal to nRT. This one just to show you what is this constant. The Boyle's law. What is this constant? Right. So you write PV equal to RT. Rearrange back the Boyle's law. Boyle's law is P and V. Boyle's law is P and V. So you write P and V form. P equal to constant 1 over P just now, or P equal to 1 inverse of R, 1 inverse of V. So your constant value is nRT. This one, this one. PV equal to constant. So if you move your P to the left, PV equal to nRT. So this is your constant value. So this is just a summary of what we learned in chapter 2. Yeah, Boyle's law, Charles' law, Avogadro law. What else? This one is combined law. Just now we do not go into this one. We do not go into gay law, right? But you know, huh? But using the ideal gas, you're able to find temperature. Okay. Now this one asks you straight away, use ideal gas law in your solution. Find the pressure of 0.8 mole of gas in a flush 1.2 liter at 298 Kelvin. Find the pressure. So PV equal to nRT. PV nRT, R is given. R you know. R you know. So T you know. N you know. V is given. Right? So you rearrange the equation. Just be careful on the unit. Yeah? Sometimes I give you the R in Celsius. You need to use Celsius. Just be careful. Huh? R sometimes is not 8.31. If I change another one into Celsius, it will be another value. It's not always 8 point something, depend on the unit. Eh? Just be careful on that. So pressure equal to 300 something kilopascal. Okay. So in our class, the value actually not very important. Important is you understand how we use the equation and what case we use the equation. Because in the test, we will change the value. We change the scenario. Yeah. Okay. Good. Yes, this one also lah. You go home and do lah. You understand PV equal to nRT. Of course, in test, it won't be this direct lah. Won't be this direct. So this again, this is just a reminder on the conversion unit. In the exam, usually we'll give you 8 atmospheric pressure. You need to do conversion, then do all the things lah. This is also another example. They ask you to find n number of moles, give you pressure, give you volume. So PV equal to nRT, you should able to have R. Then you're able to find. So same, what is missing is the n. You substitute. Just one is remember. This is a sample of when we give you the Celsius things. You need to convert temperature into Kelvin. You need to show your conversion. T equal to small t plus 273. To show these steps. In exam or test, you need to show me this. Capital T equal to T plus 273, then substitute the temperature, convert into Kelvin or Celsius. You need to show me these steps in the test or final exam with the correct unit. Then you substitute into the N equal to PV divided by RT. Press calculator, cancel out the unit. You arrive at the final answer in mole. Okay. When the final exam, you need to do something about the mole. Do something about the mole. Okay. We have a short break. 10 minutes. We continue 1:15.